Okay, girls, I am in the activity book. That is this book. And I am on page 2. And I am on lesson 1.1, thermal energy, temperature, and heat. Okay, so one thing that you really need to make sure you do is pay attention to these headers, because this tells you where to look to find the answer. So if you're not sure where to find the answer or where I'm getting this information from, make sure you look under the header, okay? Another thing that is really helpful or important is these verbs, things that you do that they have put in bold. That tells you how they want you to answer the question or how you should be thinking about answering the question. Okay, so let's hop into the first one. It says relate descriptions of energy. So when Miss Natasha thought about this relate means tell how things are connected, are related to each other. So we have two terms, kinetic energy and potential energy. And Miss Natasha wrote the definition of potential energy here and the definition of kinetic energy here. You know those and you can find them in the book. So I know that if I add potential energy, and I can actually come up with a calculation. A calculation is like a math problem. I could come up with a math problem or some functions that's like multiply, subtract, add to help me figure out how these two are related. So if I add the potential energy of an object to the kinetic energy of an object, that will actually equal its mechanical energy. So here's a calculation that you could do to figure out the mechanical energy of an object. The next one is characterize thermal energy and explain why all matter has it. Okay, so this is another thing where Miss Natasha knew she could come up with a calculation. Okay, so I know that if I take the kinetic energy of a particle and I add it to the potential energy of a particle, that will equal the thermal energy of the material that an object is made up. So I look at the made up of. So I look at the particles and that'll tell me the thermal energy of the material. One thing that you really need to notice is that we're looking at something a lot bigger here. Here we're looking at something really small. We're looking at the particles or the atoms. Yeah, that's another thing you need to remember, that the word particle, another way of saying particle, are the atoms. And here is why this is important. All matter, so matter is all solids, liquids, and gases, have thermal energy because all matter, so all solids, liquid, and gases, everything in this world is made up of atoms. So everything in this world, every solid, liquid, or gas has thermal energy because it is made up of atoms. All right, next thing, and I found next thing. It says explain how kinetic energy of the particles relates to differences in temperature represented by the picture. Okay, so we have two pictures here, and these pictures are kind of similar to the pictures that you see, I think it's like figure 3 in this lesson. So we have these little atoms. These are atoms or particles, and they're flying around. These ones are faster, and this is how Miss Natasha knows. They're faster because there's more space for them to move, and also this little shadow is a lot longer, so that tells me that they're moving a lot faster. These ones are moving a lot slower. There's more of them in one space, so these could be a gas and these could be a solid, because these are a lot closer and they're moving a lot slower. Okay, so now they want me to explain. So this means that I need to use sentences. And I need to tell them about kinetic energy. So I need to make sure I use that word, kinetic energy of the particles, and how it's different from temperature. So what is the difference between kinetic energy of the particles and temperature? So here's the first thing Miss Natasha thought. The atoms in A are moving slower than B. So since that's true, I know that that's true, I can see it. The atoms in A have less kinetic energy than B. Because remember, kinetic energy is energy that something has because it's moving. So these particles are moving slower, so they have less kinetic energy. So if this is true, so that must mean that picture A has a lower temperature than B. Because remember, temperature is the average kinetic energy of particles. And remember what an average means. I would add up how fast all of these particles were moving, and then I would divide by how many particles I see, and that would give me the average. So since these are all moving a lot slower than these, this has to have a lower temperature. And if that went way too fast for you, pause the video and try to think about what I said and how I thought about it. This is true, and if this is true, then this must be true. And if this is true, then this must be true. And here are the definitions for the really important words: kinetic energy and temperature. Next one. Assess the difference between thermal energy and temperature. So what they want you to do is figure out the difference between thermal energy and temperature. One way that Miss Natasha thinks about this is by using calculations or equations, because it's really easy to see if I use equations. It's really easy to see how things are alike and how they are different. So the first thing that I need you to know is when you see a K, that means kinetic energy, and when you see a P, that's short for potential energy. So to calculate thermal energy, you take the kinetic energy of the atoms, that's another way of saying particles, plus the potential energies of the atoms in a material. And that's the same thing that Miss Natasha had here, calculating thermal energy. But for temperature, I'm going to take the average of the kinetic energy of the atoms in a material. So the difference that I can see here is that I'm taking two different types of energy here. I'm looking at two different types of energy here, but here I'm only looking at one. So that's a major difference. That's a major difference. For thermal energy, I'm going to look at both the kinetic and the potential energy. But for temperature, I'm only looking at the kinetic energy of the atom. So I'm looking at atoms for both of them, but I'm only looking at one type of energy for thermal energy. For temperature, I'm sorry, not thermal energy. And if I went too fast, stop the video and look at it again. The last one says evaluate the difference between heat and thermal energy. So this is another place where Miss Natasha is using her equations to figure out what the difference is. So thermal energy, once again, I'm going to add the kinetic energy of the particles, and I'm going to add the potential energy of the atoms in the material. But for heat, I'm not doing any calculating. What I'm doing is I'm moving thermal energy from warmer objects to a cooler object. So all I'm doing is just transferring. I'm not doing any kind of adding. I'm not doing any kind of calculating. I'm just taking something that has thermal energy and moving that thermal energy to something that has less. Okay, next thing, relate temperature of objects to the rate of heat transfer. So remember, you might not know this, but you should know this. A rate is how fast or slow something happens. Okay, so they want to know the difference between relate temperature of an object to the rate of heat transfer. So how fast or how slow it will heat, or how fast or how slow the thermal energy will transfer. So different temperatures between the objects. So if I have two objects that the difference in temperature is really, really high, then the rate of heating will be high. So if I have something that's 3 degrees Celsius and something that is 25 degrees Celsius, that is a big difference. So how fast they switch thermal energy will be really fast. But if I have something that's 3 degrees Celsius and something that's 5 degrees Celsius, the rate of heat transfer will be a lot slower, because these two objects, or whatever, these two objects have, the difference between their temperatures is a lot slower. All right, girls, that's all I have for you. This will be really helpful when you're trying to get your notes together. So please make sure you take a look at it and stop and pause the video if you need to.